Okay, so for this next one, there is no log property that we can use to get rid of this fraction. So we really do have a variable expression divided by a variable expression, and so we need to use the quotient rule. So using our quotient rule, we will have our top function as natural log x, bottom function as x to the 6. The natural log x, again, that's going to be our u prime over u rule, or simply 1 over x. And then our x to the 6 will go to 6x to the 5th. Plugging into the quotient rule, we will have this first diagonal, and we'll plug in with parentheses. So 1 over x times x to the 6, and then minus this diagonal. So natural log x times 6x to the 5th. And then that is over the bottom squared for our quotient rule. So bottom squared here is x to the 6 quantity squared. Now we do want to simplify this if at all possible. So the first simplification comes with this 1 over x times x to the 6th power. There you would multiply straight across, and I'll just kind of do this off to the side here. So this 1 over x times x to the 6 would become x to the 6 over x, right, when you multiply straight across. Then you would be able to subtract your exponents, so 6 minus 1, to get x to the 5th. So this first term is going to simplify to become just x to the 5th power. Now, the second term, you want to bring the 6x to the 5th to the front of this term. The reason why we want to do that is we don't want there to be any question as far as what is the argument of this natural log. So we're always going to put our e to a power and our log functions last, so that there is never any question about what is the argument. Specifically for log, it is very important to put those log functions last. So this will become 6x to the 5th natural log x. And then that is over, and I should mention I'm dropping these parentheses because it is just one term times one term, but we do want to put the log term last. All right, and then in the denominator, we have this x to the 6 raised to the 2nd. So you'll notice here that that is an exponent raised to another exponent. And this is going to happen a lot in these questions when you have this b squared. So when you have this exponent raised to an exponent, you will multiply those exponents together. So that will give us x to the 12th power. Now, you could potentially factor out the GCF. They probably are not going to request that you do that, so this would be your final answer. However, I do want to just tell you very quickly, if you were to factor out the GCF in the numerator would be an x to the 5th. That would give you, from this first term, if you take out x to the 5th, you're going to have x to the 5th divided by x to the 5th. That's just going to give you a 1. From the second term, if you take out the x to the 5th, you'll be left with 6 natural log x. And then this is over x to the 12th. Now, the cool thing here is that once you take out that GCF, then you have x times a quantity. And so if you look at just this x to the 5th over x to the 12th, you can subtract those exponents. So again, if it was just this, you would simplify the x to the 5th over x to the 12th. So if I subtract those exponents, I get 1 minus 6 natural log x over x, and then taking the 5 minus the 12, that will leave us in the denominator as a 7, so x to the 7th power. So again, they're probably not going to mark you wrong if you don't do this, but that is your most simplified version, taking out the GCF.